So this is the Math12550 10N04 Precalculus with Workshop review for Exam 4. This review is on conic sections, that is circles, ellipses, and hyperbolas. And we're going to be doing some problems from the review session, from the review sheet. So first, we're going to do number 5 from the review sheet. Number 5 actually number 4. We'll do number 5 right after. We're going to do number 4, which asks us to find the center and radius of the following circle. Of the circle 3x squared plus 3y squared minus 24x minus 12y plus 33 equals 0. Now, if a circle is given to us in this form, we have absolutely no idea what its center or radius is. What we need to do is we need to put it in its standard form. The standard form of a circle looks like this: x minus h squared plus y minus k squared equals r squared. And once we get our circle to look like this, then we can conclude that the center of such a circle must be h comma k, and the radius of such a circle must be r. But first, we need to get it to this form. And in order to get it into this form, we essentially need to complete the square for both the variables x and the variable y. So our first step is to make sure that the coefficient of the x squared and y squared terms is 1. And so one way to do this is to divide out the whole equation by 3. So we do that, and we get x squared plus y squared minus 8x minus 4y plus 11 equals 0. Now there are several different things you can do, all of which are correct. One of the things that I like to do is put the constant, in this case 11, on the other side. So, and then also put the x's together and the y's together. So I'm going to rewrite this as follows: x squared plus x squared minus 8x plus y squared minus 4y equals negative 11. So now that I wrote it like this, I'm going to complete the square with x's and then complete the square with y's. So what I want to do, I want to write this as x squared minus 8x, and then I want to add something here. And then I'm going to do the same thing for the y's. I'm going to add something. And the crucial step in completing the square is we have to add the same thing to both sides. So what I'm going to do, I'm going to figure out what I need to add. Well, if I have x squared minus 8x, I need to add something to make it into a perfect square. And again, a general a rule for completing the square is if you have an x squared plus bx, what you do to complete the square is you add b divided by 2 squared. And this becomes equal to x plus b squared. This is how you complete the square. You make this into a square. So what I'm going to do here, I have x squared minus 8x plus what? Well, I have to take my negative 8 divided by 2 and get negative 4, and then square it, and then I'm going to add 16 to both sides. So if I add 16 to one side, I have to add 16 to the other side. Now I do the same thing with y's. I have y squared minus 4y, and what I need to do is I need to add a 4, that's negative 4 divided by 2 and squared, and I have to do the exact same thing on the other side. And now I can rewrite my equation for the circle as follows. I can now rewrite this as x minus 4 squared plus y minus 2 squared equals 9, since negative 11 plus 16 plus 4 equals 9. And so now I have my standard form for this circle, and now I can conclude what its center and what its radius is from this information. Now it's in standard form. And so I can conclude that for this circle, the center occurs at 4, 2. And I can also conclude that its radius is the square root of 9, or 3. Okay, so what we need to do if we're not given a circle in standard form is to first convert it into standard form by completing the square, possibly twice, and then extracting from it the data of the center and radius. So this is what we do for circles. Next, we're going to look at ellipses. So in the next problem, we're going to look at an ellipse centered at the origin. And so we are given an ellipse, and we're asked to identify several things about it. The center, the vertices, the co-vertices, the foci, and graph. So we need to get all this information from the ellipse given to us by this formula, x squared divided by 4 plus y squared divided by 49 equals 1. This is our ellipse from which we must extract all the information. Now this is given to us in standard form, and you're going to have a reference sheet on the exam, and the reference sheet is going to tell you the general form of an ellipse, the standard form of an ellipse. In this case, this is x squared divided by b squared plus y squared divided by a squared. We have to look, when we look at an ellipse, what is bigger, the denominator under the x squared term or the denominator under the y squared term. That is going to determine which one of the two types of ellipses this is. So this ellipse, from our reference sheet, we can gather that the center is at the origin. We can also gather that the vertex, the vertices, are going to be on 0 plus minus a. The co-vertices for such an ellipse are going to occur at plus minus b, 0. The foci, the two focus points of the ellipse, is going to occur at 0, plus minus c, where the relationship between a, b, and c are as follows: c squared minus equals a squared minus b squared. Again, all this information is on the reference sheet, but you need to match the given problem to that on the reference sheet. So now, what we're going to do is we're going to figure out what is a, what is b, what is c in this particular problem. So for this ellipse, the center is at the origin, we know that A here is 7. And that B is 2. A in the ellipse, A is always going to be the bigger one. So in this standard equation for the ellipse, we are assuming that A is bigger than B. So you have to look under which, what is bigger, what's under the x squared or what's under the y squared. And now we need to figure out C. Well, C squared is going to be A squared minus B squared. So C squared is going to be 49 minus 4. That means C is going to be the square root of 45. And we can simplify this radical to, since 45 is 5 times 9, we can extract the square root of 9 from it. And this is going to be 3 times radical 5. And so from this we can gather the following information about our ellipse. We can get that the center, we got that the center is 0, 0, so now we want to get the foci, the vertices and the foci. The vertices of our ellipse is going to be 0, plus minus 7. The co-vertices of our ellipse is going to be a plus minus 2, 0. And the foci of our ellipse is going to be at 0, plus or minus 3 times radical 5. So when we want to sketch the graph of this ellipse, it's going to look like as follows. This is 1, 2, negative 1, negative 2. It's going to be longer than it is wide because the larger number is under A. So if we want to graph our ellipse, it's going to look like this. And if we wanted to plot the two foci points, we can estimate it. Square root of 5 is a bit larger than 2, so 2 times 3 is somewhere a bit larger than 6, so we're going to have our foci somewhere here. So this is the graph of our ellipse. And so if our ellipse was not given to us in standard form, then we would have had to first put it in standard form and then extract all this information from it. Okay. So in the next problem, we're going to be given an ellipse not in standard form, and it is our job to put it in standard form. So the next problem that we are going to do is number 8. From the review sheet, we are given to rewrite in standard form the following. We have 4x squared minus 8x plus 9y squared minus 72y plus 112 equals 0. This is an equation for an ellipse. Even if we were not told this is an equation for ellipse, we could tell because the coefficients of x squared and y squared are different. If they were the same, if they were both 4, they were both 9, this would be the equation of a circle. But because they're different, this is the equation of an ellipse. And the standard form of an ellipse not centered at the origin, according to the reference sheet that you're going to be provided, will look like this. X minus h squared divided by a squared plus y minus k squared divided by b squared equals 1. So this is what we're trying to get our equation to look like. This is the standard form of an ellipse with a center at h comma k. And so, again, we need to complete the square. However, it's a bit more trickier in this case than it was for the circle because there are different coefficients multiplying the x squared or the y squared. Now, there's several different ways to do this, and I'm going to show the way which I think is the fastest. So one thing that I like to do is I like to put the constant on the other side. You don't have to do this. You can work with everything on one side, but my preferred way is to put that constant on the other side. And now I want to complete the square, but I have a little problem. The coefficient of x squared is not 1. So what I'm going to do is, in this case, I'm going to factor the 4 out, and I'm going to rewrite it like this, 4 times x squared minus 2x, and from the next two pieces, two terms, I'm going to factor the 9 out, and I'm going to have this. So if I factor the 9 out, I'm going to have 9 times y squared minus 8y. And now I want to complete the square. And now I'm going to complete the square inside the parentheses. And I'm going to complete the square inside the parentheses as well. You can do this, but then you have to adjust what you are adding to the other side so that you are doing things that's mathematically legal. So if I look at x squared minus 2x separately, the first thing that I'm trying to complete the square for, I need to add something to make this into a perfect square. So I add 1 because, again, remember, if we have x squared plus bx, we want to add b over 2 squared, and this is going to give us our perfect square. That's the formula, strategy for completing the square. However, I now need to figure out what do I need to add to the other side to balance out what I just did. And in the case of a circle, we just added 1. But here we can't add 1 because this 1 is inside the parentheses, which is being multiplied by 4. So what we have to do is we have to add 4 to the other side to balance this out. So we add 4. What we essentially did is we added 4 to both sides. Next, I'm going to complete the square with the y's. I have y squared minus 8y, and I'm going to add 16 to that. But now I have to balance it out with what I did on the other side, and this 16 is inside the parentheses, which is being multiplied by 9. So I have to add 16 times 9 to the other side, which is 144. And now I'm ready to write this as perfect squares. So now I have 4 times x minus 1 squared plus 9 times y minus 4 squared. And if I add up all the numbers, negative 112 plus 4 plus 144, I'm going to get 36. Now I'm almost there, but I'm not done because in the standard form of an ellipse, I have to have equals 1 on the right-hand side. So my last step is to divide everything by 36. If I divide the first term by 36, I'm going to get 4 divided by 36, and I'm going to get x minus 1 squared over 9. Next, I'm going to divide the second term by 36, and I'm going to get 9 divided by 36, which is 4. And finally, on the right-hand side, I divide 36 by 36, and I'm going to get 9. And so this is an ellipse with center 1, 4. And this is the final answer. This is me rewriting the ellipse in its standard form. X minus 1 squared divided by 9 plus y minus 4 squared divided by 4 equals 1. In the next problem, we're going to be already given an ellipse in standard form, and then we're going, not centered at the origin, and then we're going to extract all that information from it. So the next number we're going to do is number 10. And number 10, we need to identify the center, vertex, vertices, the center, vertices, co-vertices, foci, and graph of the following. In this case, it's given to us in standard form. This ellipse, x minus 2 squared divided by 49 plus y minus 4 squared divided by 25. If this wasn't given to us in standard form like this, we would have had to convert it to standard form. And now we look at the reference sheet, and again, the reference sheet has the standard form of an ellipse centered at not the origin. So if we have such an ellipse, x minus h squared over a squared, y minus k squared over b squared equals 1, then its center is going to be h comma k. Notice this is the case where a is greater than b, and the a bigger one is under the x squared. The vertices in this case are going to be h plus or minus a comma k. The co-vertices are going to be h comma k plus or minus b. Again, this is all in the reference sheet. And the foci are going to be h plus or minus c comma k, with c squared equals a squared minus b squared, and in this setup we're working with a as the bigger one. So this is what you have on your reference sheet, and now let's extract all the relevant information. So first we identify what a is. A in this case it's 7, as 7 squared is 49. B is 5, and c, well, c squared is going to be a squared minus b squared. So c squared is going to be 49 minus 25. So c is going to be the square root of 24. And we can simplify that into 2 times 6. 2 times square root of 6. And so now we can get all the information that we want. The center of our ellipse, read straight from the standard form, is 2, 4. The vertex, the vertices of our ellipse is going to be 2 plus or minus 7, 4. So this means the vertices are negative 5, 4, and 9, 4. The co-vertices are going to be 2, 4 plus or minus 5. So that means they are 2, negative 1 and 2, 9. And finally, the foci are going to be 2 plus or minus 2 times radical 6, 4. So this is all the information that we extracted simply from figuring out what is A, what is B, what is C. And now we're going to graph it. And the first thing that we put on the graph is the circle, is the center of our ellipse. So in this case, the center is two comma 4. So 2 comma 4 is the first thing that we're going to put. It's not part of the ellipse, but it is going to help us orient our graph. So the very next thing, once we figure out where the center is, we plot the vertices. The vertices are -5 comma 4, which is here, and the second vertex is 9 comma 4, which is right here. And then we look at the co-vertices. The co-vertices are 2 comma -1, somewhere here, and the second one is 2 comma 9, somewhere here. And now we really have the general idea of what our ellipse is going to look like. And we can kind of approximately plot the foci. The foci are going to be approximately somewhere here. Okay, and this is a good graph of our ellipse, and we got that from all the information: center, vertices, co-vertices. For our last problem for this part of the review, we're going to identify and sketch a hyperbola. So we are asked in number 13 to identify the vertices, foci, and graph of the following hyperbola. Hyperbolas are other types of conic sections, and we can always distinguish hyperbolas from ellipses is that a hyperbola is going to have a minus sign in front of one of the quadratic terms. And we're only doing hyperbolas centered at the origin. And the general form of a hyperbola centered at the origin looks like x squared divided over a squared minus y squared over b squared equals 1. For hyperbolas, we carefully look at where the minus is in front of it. If the minus is in front of y squared, then the hyperbola is going to be repelled from the y-axis. So in such a hyperbola, this is centered at origin. The vertices are going to be plus or minus a comma 0, and the foci are going to be plus or minus c comma 0. Where the relationship between a, b, and c is a little different from ellipses, it looks like this: c squared equals a squared plus b squared. So in this case, in our case, we first identify a is 5. Doesn't matter here which is bigger, a or b, we just look at where the minus sign is. And b is 6. So this means c squared is a squared plus b squared is 25 plus 36. This means that c is the square root of 61. And now we can gather that the vertices are going to be plus or minus 5 comma 0, and the foci are going to be plus or minus square root of 61 comma 0. And when we want to sketch this, so remember the minus is in front of the y-axis, so the hyperbola, the two pieces of the hyperbola is going to be turned away from the y-axis. So we have 1, 2, 3, 4, 5. And first we plot the vertices, that's our starting point. We plot the vertices at plus or minus 5, plus minus 5, comma 0. And then we can give a rough sketch of a hyperbola from there. The hyperbola is going to look like this. It's going to be repelled from the y-axis. And the foci of hyperbola is always beyond the curves, unlike being inside the curves for the ellipse. So this is a good sketch of our hyperbola. And we're only doing hyperbolas centered at the origin in this class.